Hello and welcome to this short introduction to spectroscopy. We will use this in the analysis of the chemical composition of a certain gas by studying the interaction between matter and electromagnetic radiation. Do you know this type of diagram? It shows sunlight after it has passed a prism that splits it up in its different wavelength components. It's a spectrum. But at some places along the spectrum we see black lines where we would expect to find light. These lines were studied by the German physicist Joseph von Fraunhofer at the end of the 18th century. 50 years later, two other German scientists came up with an explanation. They found that the black lines are caused by absorption by chemical elements in the solar atmosphere. Knowing that the sun emits radiation containing all wavelengths, they concluded these lines give us a hint on which chemical elements are present between the location where that radiation is generated and where it's received. This is the basic technique of spectroscopy. Spectroscopy is a very powerful technique since we can sense a gas indirectly without putting a sensor in contact with it or collect samples from it. Instruments which provide us such spectra are called spectroscopes, and they can be simple instruments like the one shown here. They can also be complex systems with lots of electronics that provide even small and faint spectral features of a certain electromagnetic range. In general, we have to distinguish between absorption spectra and emission spectra. On one hand, in the case of absorption spectroscopy, we have electromagnetic energy absorbed or damped at certain frequencies when it passes through a gas. On the other hand, we have gases which emit electromagnetic waves at certain wavelengths because atoms or molecules make transitions from a so-called high energy state to a lower energy state. In order to illustrate absorption and emission, we need to look at what happens on an atomic level. Somewhat simplified, we can say that we assign a certain energy level to an atom. Let's call this energy level E1. If a photon or electromagnetic wave with a certain frequency and energy called delta E interacts with the atom, it's possible that the atom absorbs this energy to reach the state E2. In general, atoms have only discrete energy levels, which means that only discrete energy levels can be absorbed. As the energy of an electromagnetic wave or a photon is directly related to its frequency, this implies that the energy at certain discrete frequencies is absorbed. That's the reason why we get these distinct black lines in the sun's spectrum. These are characteristic for all the atoms and molecules that are found between the electromagnetic source and the spectrograph. In the case of emission, atoms or molecules are at higher energy state, E2, to start with. When they change to a lower energy state, E1, the difference in energy is emitted as an electromagnetic wave. Again, as atom energy levels are discrete, they can only emit energy at discrete levels, which also means waves with discrete frequencies. There are several reasons why atoms are on higher energy levels. A classical example of emission is a light bulb. A neon light bulb is a small glass capsule which contains a mixture of neon and other gases. When you turn on the light, an electric current will flow and bring the neon atoms to a higher energy state. When the atoms return to a lower energy level, the difference in energy is emitted as visual light. That's the reason why we see very distinct lights when we analyze neon light in a spectrograph. This is a typical emission spectrum. Absorption or emission spectroscopy. Both are great tools for geoscience. They enable us to sense a gas remotely. This can be very useful when the concerned region is too difficult to reach, too dangerous for humans to study directly, or when instruments could be easily damaged. Keep this in mind, since spectroscopy is useful when sensing all spheres of planet Earth. Very good. I hope you like this lecture and that you will find it useful as a precursor to upcoming lectures.